Problem number 29 is an example of what is called a compound inequality. Now what we're looking for are the values of x that make this statement true or this statement true. At least we want to find the values of x that make at least one of them true. So let's solve each one individually. Let's start here with this one here. All right, so the way I'm looking at this is that we have x's on both sides. I've got more x's on the left than the right, so I'm going to subtract these two x's. Right, so I'm going to subtract the two x's, so I'll get x minus 1 strictly greater than 4. Let's add that 1. So x is greater than 5. So any values of x that are bigger than 5, strictly bigger than 5, will make this statement true. Now which values are going to make this inequality true? So let's solve this one. So I'm looking at it here. I've got x's on both sides. I've got more on the left. So I'm going to get all the x's on the left side. So I'm going to subtract these 3x's. So 5x's minus 3x's, 2x's. Minus 2 is strictly less than 4. We'll add the 2. We'll get what 2x is strictly less than 6. Divide. Okay, now be careful. Alert, we're dividing an inequality. So I just have to slow down for a minute. I'm dividing by positive, so no change in the direction of the inequality sign. We'll get x is less than 3. So if I pick any number less than 3, strictly less than 3, we'll get a true statement here. So let's put both of these on a graph. Now I'll draw a number line here. Our variable is x. And what points are we going to use? I'm on a 5 and a 3, and they're strict inequalities. So we're going to have open circles, or if you like, parentheses. I'll use parentheses this time. Now, we're going to be here at 3 and 5. First of all, I'm going to draw open circles. Now, where do I want to go? I want the x's to be greater than 5. So the x's are going to be over here to the right of 5. So I'll shade that in. Or I could be over here to the left of 3, right? The arrow goes to the left, so I could be over here to the left of 3. So I could write my graph like that, or I could write it like this. Now I get an open parentheses here around 3, open parentheses at 5, shade those, so either graph will do. And then to claim the solution, to state the solution, I'm just going to look at my graph and see where I am. Well, where are the x's here? They're all the way out to negative infinity, up to but not including 3. So I can write that like this. Open interval, negative infinity to 3, open, right, because the 3 is not included, and it's open around an infinity because infinity is not a number. So I always need to have parentheses, open parentheses around an infinity. And then over here, on this side, we're out from 5 all the way out to positive infinity. So this is going to go, now 5 is not included, so parentheses, 5 out to infinity. And I want an or. Now the symbol, in the mathematical symbol, the set series symbol for or is this union sign. So that symbol right there is read as union, and it means or.